welcome to my lecture on power series. We're going to determine the interval convergence of the series written down. And unlike the last lectures where I used the ratio test, which we could use here, and that would be completely fine, I'm going to use the root test. Either one of them will answer this question of determining the interval of convergence. But just for some variety, I'm using the root test. And probably, just because ratio test is my favorite, I might use that most of the time. So I'm going to use the root test, and a sub n is going to be x minus 2 to the nth power divided by n to the n power. Okay. And one thing that I'll say here is this is a good candidate to use the root test because everything has the nth power as an exponent. Okay. So this root test is going to say, let's compute this limit as n goes to infinity of the nth root of the absolute value of a sub n. Now, instead of having the nth root written that way, I'm going to put it to the 1 over n power, and I'm going to have absolute value of x minus 2 to the n divided by n to the n power. Now, using properties of exponents, I'm going to be left with absolute value of x minus 2 divided by n. Now, this limit, as n goes to infinity, is for a fixed value of x. Whatever the value of x, the denominator is what's going to infinity, and therefore this limit is 0. That is L. So, by the root test, the series was writing two things at once there. The series converges for L equals to 0 less than 1. Hence, for all x, so the interval of convergence is minus infinity to infinity, every single value of x. Okay. Minus infinity x less than infinity. Okay. So there's our interval of convergence. It converges for every single value of x. Okay. Now, something that I would point out here is since this interval is infinite, the radius of convergence is equal to infinity. Okay. Now, one thing that I'd point out is that this series has something that's called a center. The center is the thing that makes every single value of the series 0, the x value. And the center is x equals plus 2. Okay, that's our center. All right, well, thank you for joining us. This was our first example where the interval of convergence was infinite.